Colbert jokes about how you're creating a squid man in your lab, or the potential for it. Is there anybody who is actually auditing or creating limits around this type of genetic development?
I have encouraged limits, that is to say, and not just voluntary. I mean, I've encouraged discussions. Ours is one of the few, biotech technology developing groups in academia that also does, kind of active innovation in bioethics. So we have a full-time bioethicist, Jantine Lonsoff, and there are innovations that you can have. So it can have surveillance of synthetic DNA to see if people are asking to manufacture things that they're not equipped to handle or haven't documented what they want to do with it. So select agents and so forth. That was one of the 2004 suggestions. The Personal Genome Project is a bioethics strategy for dealing with privacy concerns. We have around the gene drives. The first 3 papers we did were all cautionary about how to, do it in a way that's reversible or monitored and so forth.
But you can't really stop that. If someone can get this technology, is it a very small group of you that are this advanced?
I think that if you say you can't stop it, then it becomes much more likely you can't stop it. But if you do everything you can get a virtuous cycle that gets people more and more excited about doing things the right way. And that you build a culture of, so you can have, in the robotics world, you have the culture of robot wars. That's how they intentionally, the initiators, the entrepreneurs, felt that was a good way to train the next generation. Well, in synthetic biology, we've gone the other direction, where we've asked for human practices and very considerate and transparent discussions. And surveillance goes beyond transparency. Transparency is often voluntary, or it has a component of cooperation involved. But with surveillance, you can try to be more and more invasive into, if you're a synthetic biologist or have any synthetic biology training, there's absolutely no reason why you should have any privacy. Nobody forced you to become a synthetic biologist, and so you should acknowledge that everything you do on and offline is going to be looked at very deeply.
I found 2 metaphors on how genetics are working today. One that you're concerned about is this sort of bank relationship where we give something to the bank and they give us something back, and that's not happening in genetics, which is why you started the Human Genome Project. But also I found that there was a metaphor with the Catholic Church where everything was in Latin and no one but the priest could understand it. Can you talk to me a little bit about what's happening today?
I don't know the context of the bank analogy, but I think with the liturgy or the religious texts, the breakthrough was the Gutenberg Bible that made it available in print rather than just illustrated manuscripts, and then the translation into common languages made it available to people in general. So that concept of education of the masses rather than the priesthood, I think, was very important. So I think we're more analogous to Wikipedia. It's not that you make a deposit and you take something back. Well, in Wikipedia, you can edit the articles if you have something to contribute. Other people will check to make sure that you edited it correctly. But then you take out of it anytime you want information that's fairly well vetted, you have a resource, and that's what we're trying to do. There was a time where most of encyclopedic type information, even post-Gutenberg, were in these silos of proprietary books, and then Wikipedia completely changed that. And if I were today trying to put genetic information in little silos and protecting them the way we used to protect encyclopedias, I would be looking over my shoulder at the Wikipedia version, which is the Personal Genome Project. So Wikipedia is the analogy for sharing. The analogy for understanding, I think, is global positioning satellites. Global positioning satellites, very complex technology, large-scale integrated circuits, thrust up into the sky with Newton and Einstein, and then precise timing and atomic clocks. You don't need to worry about that. When you pull out your phone, you just ask, am I turning left or right, right? And so the key to understanding isn't understanding every single thing in the world at the atomic or subatomic level. It's having great software. Because that's how you can relate to it. People understand weather. Part of the reason they're fascinated with stars is they used it for celestial navigation. Now we actually understand stars less than we used to, not more, because we don't need it for navigation anymore. But we understand GPS a little bit better than we used to, right? And other satellite things. So I think it's really you understand as much as you need in order to make technical decisions, like which cell phone to get, and whether to vote for global warming or not, and that sort of thing. And that's what we need to do with genetics. That's what we are doing with genetics. I mean, you can get not just 23andMe, which is just a few SNPs, and it's mainly aimed at ancestry at this point. But you can get your whole genome sequence, and you can find out if there's anything actionable. And if there isn't, that's very easy to understand. Nothing to do right now. Come back a few months and see if it's changed. But if there is something to do, then the understanding will be take this slip of paper to a physician and ask for this test.